In this video, I'm hanging out again with my new buddy, Craig Migilaccio from acservicetech.com, and we're talking about leak detection. Craig is an unashamed fan of ultrasonic, so I talked to him about that a little bit. And in general, we just have a talk about some of our best practices that we've learned in the field. Craig has a whole bunch of these types of practices and more on his website, acservicetech.com, and in his book that he's written for AC service technicians. So take a look at that when you get a chance, but hope you enjoy this video. Craig and I talking about leak detection. Leak detection. And specifically, I want to get your take on ultrasonic leak detection. But first, I want to give my experience and have you diagnose my experience. Because I've never been able to make ultrasonic leak detection work. Like, when I try to find an evaporator coil leak, you know, your typical formic leak on an evaporator coil, I just never got a result. But I also didn't ever put the work in, you know, so I'd take the little parabolic probe, not the parabolic, the just little probe, and I just never pick up anything. Let's start there. Why do you think I suck so bad at ultrasonic leak detection?
Ultrasonic leak detection works really well when you have the oil that has been slung through the whole system. If there's oil on the inside of the tubing, so it works best right after you shut the system off and it's equalizing, and so you have that oil over the leak location. And so it makes a squealing noise as it exits through the tube.
Interesting.
Also, on the outside of the tube, it works, in my experience, has worked great on evaporator coils because they're already wet, you know, during air conditioning mode. Between the oil on the inside of the tube and the water on the outside of the tube, it makes a distinct squealing noise, and sometimes I can hear it as soon as I open the door to an evaporator coil. Sometimes I have to get the tube close enough to where the leak is, but what I do like about it is that I feel and I have confidence to where if I go past where the leak is, it doesn't matter how fast I go, doesn't matter if there's like wind pushing the chemicals away from my sniffing tool, and I feel like I just go right past it and I pick it up immediately, and then I can just kind of go into it. I feel like I have confidence going past the leak spot locations. However, it's not going to make as good of a sound if all the tubing is completely and 100% dry on the inside and the outside. I don't know why you haven't been picking up a leak.
You can say it. You can say it. Here's a lack of talent. Use your error.
Did you have the earphones on your ears, or was somebody else wearing them?
I didn't plug the earphones in. I'm like, this thing isn't doing a thing.
Darn it.
It's funny. It's just back up. I've only tried it a few times. And I actually had one of them sent to me at one point early on in HVAC school, and they're like, here, test this out, see how you like it. And I'll admit, I got really impatient with it. It was a coil that was sitting out here in the shop that had a known leak, and I was able to pick it up with an electronic, and I couldn't notice anything. But it's an interesting point that you make. So it sounds like the squealing noise is largely the vapor passing over liquid then, right?
Yes, absolutely, yeah.
Okay.
I mean, it makes the noise become so loud. You know, once that happens, the ultrasonic noise. So maybe in that instance, there was no refrigerant oil near the leak on that evaporator coil, potentially. If I had an evaporator coil out of the system, before I would even start searching it, I would probably hit it with a spray bottle, spray water all over, or just hit it with a hose quick. If it was literally outside and I had a pressure test on it, that's exactly what I would do before using the ultrasonic leak detector. You may not want to do that, you know, and so you're just trying to sniff with something, a heated diode or infrared or something like that. You're trying to pass by the leak location. So everybody has their own methods, and it's helped me to find leaks I couldn't find before, and that's what kind of pushed me over the edge on evaporator coils where it had like, say, 3 tubes deep, and the leak was so tiny that you're not going to get enough chemical out to smell it with a detector. Now, I've seen, you have some videos out there that the sniffing tool reacts to an extremely small amount of chemical, and that might be the solution. Feeling on the whole thing. Do you, as a technician, have 3 leak detectors in the truck? If you have 3, you have 2 too many. Some people have 5 of them, and they're all like $200-$300 models. Every time that you take one out, if you don't have confidence in that one or don't know how to try to find leaks with whatever one that you choose to use, you have to figure out a way to have complete confidence in that tool and know how to orient yourself to have the best results.
Yeah.
And so that's really all it comes down to, regardless of which leak detector you use. And you can't just use bubble leak detector,
Right.
because you'll be sitting there forever. I've done it. When I started out in the field,
Right.
I had leaks, and I would take the evaporator coil cover off. I would soap up all that, soap all the joints and the lines, everything. After all that time, and then I just wouldn't find the leak. Now that's great because in the essence of the bubble leak detector it was easy for me to find leaks that are obvious
Right.
on the 90 joints and things like that on evaporator coils. But you got to have some way of and some confidence in the tool that you're using.
Yeah. No, that's absolutely. I mean, I use the H10 for most of my early career because it's what old Dave Barefoot taught me on. That's what he had and that's what I used. But you pointed out, like the challenge is that even the older models, they wouldn't react with your modern HFC refrigerants. Some of them wouldn't react at all. And regardless, with modern HFC refrigerants, you don't get the level of reaction that you used to get. And now, look at what the manufacturer says it is. I'm not disputing with their findings, but from an experience standpoint, technicians know that when we were looking for R22, it was a lot easier than it is nowadays. It just is. And so I think finding some different tools to have in the toolbox to use, it sounds like you would probably still be pro, having a heated diode or all of a sudden my mind went blank on the other
Infrared.
one. Infrared, that's right. A heated diode and infrared in addition to an ultrasonic though, right? Or would you potentially only use ultrasonic?
What it comes down to is the company buying the tools or is the technician buying the tools, and it comes down to a lot of that type of thing because a lot of technicians say they're not willing to buy an expensive leak detecting tool. So they just want to have a leak detecting tool that's
Right.
under $300, whatever that may be. And some of those, unfortunately, no matter which way you go, heated diode or ultrasonic, it's just not good enough of a tool, potentially. Maybe, maybe somebody's going to come into the market that has a lower cost tool that, it works every time. I'm not against having multiple ones. I have a heated diode and I have ultrasonic, and I like to have both of them. But here's what I want to get across is no matter what you use, you want to find the tool that's most well-versed for all refrigerants and nitrogen pressure test or whatever you're going to do. You want to have one tool that you can go across, the whole system, because every time you go across the whole system is wasted time.
Yeah.
And then if you find yourself at any point with any tool second guessing yourself, did I capture it the way it should be captured, meaning the chemicals or whatever it may be, that's what I don't like.
Right, the second guessing.
Yeah, I don't like second guessing myself. I don't care what tool you use.
Right.
Just make sure that you're so well versed in it that you have confidence and are able to find the leak quickly, effectively the first time.
Mm-hmm. In your experience, you're pretty much able to do that with ultrasonic every time, would you say?
I feel like I can, yes. But like I mentioned before, if you're installing a new system from scratch and everything's completely dry, you're going to want to soak the joints down on the outside in order to try to find the leak. I wouldn't start looking for it without doing that because I want to make sure that there's going to be some type of squealing that's going to happen while I'm leak checking. You do know if there's a leak, at least in the system, with a nitrogen pressure test. And one of the things that we used to do is you'd pump the unit down. If you had a existing system, you'd pump that unit down, you'd fill it up with nitrogen, and then you start cutting sections apart and pressure testing those sections individually in the off season. All these laborious and time-consuming things we used to do, or put dye in it and come back and look around. But you want to have some way of finding it the first time. So on an existing system that has refrigerant oil slung through the whole system, I would probably go for that ultrasonic leak detector pretty much right away, just because I'm at that point with that tool that I have confidence in it. And like I said, that doesn't mean everybody needs to go that way. You may have confidence in a heated diode leak detector that picks up R22, R410A, or whatever other refrigerants that you're looking for. As long as you have confidence in it, I'm for you.
Yeah. How long have you used it about?
Probably about 4 years, I think. So I'm using that AccuTrack VPE GN Pro, so it has that flexible neck on it, and that's made by Superior Signal Company. So that's the one that I find the most useful. I did a bunch of research on that tool, on ultrasonic leak detection, because I was looking for an answer. I was looking for an answer because I was so frustrated with trying to find leaks that I wanted to find one that I could gain confidence in. And once I got it, I started finding the leaks I couldn't find before because they were so small. That's what impressed me with it, was just the very, very, very tiny leak that would just barely bubble, just barely.
Okay, yeah.
and I couldn't find it, and it would drive me crazy because every year you're having to go back and recharge the system. You feel like a failure because you can't find this leak, no matter what tool you put across this, and all the time you spend on that. So frustrating,
Yeah.
you know. And so that's what made me switch over to that.
Nice. Well, I guess I need to give it another try then. That's what it sounds like. And now I feel like a failure. You know. Okay, fair enough. I know
I've seen some of the videos that you put out, and some of the tools that you're using, and those ones work. You know, so it's whatever you have confidence in.
So let's talk through just some of the technologies really quick for somebody who isn't familiar with just the options that are on the table, and we'll kind of just talk through positives and potentially negatives for each one, or not even tools, but just processes in general. First off, for people who are newer, sometimes people don't get the difference between a pressurization test that you would do with nitrogen and doing a leak search with an electronic detection. So let's hit that quickly.
In reference to a pressure test, if you have an existing system, you can't put nitrogen in it because you have the refrigerant in there. You would need to pump that system down if it has a reciprocating compressor, or you're going to have to just close the valves and recover the refrigerant out of that system if it has a scroll compressor. And once you pull all the refrigerant out, you just have refrigerant lines that are empty and at atmospheric pressure. At that point, you're going to add inert gas, such as nitrogen, and you're going to put that into the system. But here's one thing that's a big thing for me when I'm teaching in the classroom is you don't want to overpressurize the system. I feel like there's a lot of leaks that are made by overpressurization on older systems.
Yeah.
And what's funny is a lot of those older evaporator coils, they used to be made for heat pumps. Some were made for heat pumps and some were made for air conditioning systems.
Right.
Well, the ones that were made for heat pumps were designed for a max design pressure that was much higher than these older ones were. So in the case of an old R22 evaporator coil, it may have had a max pressure, design pressure of 125 psig.
Right.
And here you're there on an existing system that has, a rusted galvanized touching the copper and it's prone to leaks. And here you go pressurizing it up to 350 psi and you make a leak. Oh, I found the leak. But you just made it. You just made a bunch of leaks, actually.
Right.
That's no good.
That's the old saying, if there isn't a leak, I'm going to make one.
Oh, jeez.
I've heard far too many technicians say that. As a joke, hopefully. So yeah, exactly. Nitrogen pressure can be overdone. Obviously, you're not going to have any leak detector that is actually sampling the gas that's going to work with nitrogen. Right. And that's something that I think a lot of newer technicians miss. You can't just use a heated diode or an infrared or really any of those types of sampling designs with nitrogen alone, because most of our atmosphere is made of nitrogen. And I always forget what the number is. It's like
around 80%.
80%, yeah, right about that.
78.
So if you had something that would sample on nitrogen, it would be going off all the time because our atmosphere is made of nitrogen. The air is made of nitrogen. But nitrogen can be used because it's inert and it's not going to react inside the system because it doesn't have that oxygen content. It's dry. It doesn't have. It has very low level of moisture content. So it allows us to boost up that pressure so that we can do one of two things. We can either do a bubble test, we can do a standing pressure test, or you can potentially do an ultrasonic test with nitrogen as well. So you have those options afforded to you. But what you don't do, because I've seen newer technicians who sometimes maybe they come out of school and they start to get ideas mixed up. They're like, okay, well, this system's leaking, so let's do a nitrogen test. It's like, all right, well, first, like you said, decide, do we have refrigerant still in this system? Because if you do, then go ahead and do a leak search before you even go doing any of that other stuff. You only go to doing nitrogen once you don't have refrigerant in the system if you're starting off in the first place, for example.
Yeah, so, you're hitting great points because I remember that myself, with students in the classroom, they would get confused on how do you leak check? Yeah, so if the system has refrigerant in it and it's leaking, don't take any steps yet. Just look for that leak with your leak detection methods, whether that's a heated diode, infrared, ultrasonic, or even just anti-corrosive bubble leak detector. Make sure you don't use soap and water bubble leak detector because I've seen that stuff eat through tubing and it's just not good. And you can't get it. Seemingly, you can't get it off. But you have a new installation and you just got done brazing and you're flowing nitrogen, hopefully, while you were brazing. And now you're going to put a pressure test on that. You're going to look at the max design pressure at the evaporator coil as well as the outdoor unit. The indoor coil, which is also known as the evaporator coil for at least air conditioning mode, that one will have a lower max design pressure, so you're going to go by that. Now, you don't have to put it up that high because some of them are rated for 550 psi, and you may be working with compound gauges that only have 325 psi max on the compound gauge, which will be the low side, the blue gauge. And so you can't really utilize that. But what is really good is if you use a digital manifold, because you can see that incremental change real easily.
Yep, that tiny pressure drop.
Yep. That's real important to use a digital manifold. You're just going to wait, do a standing test, and just to see if that nitrogen pressure is going to fall. And you also have to monitor your temperature as well. If the temperature changes, your nitrogen will change. A lot of people think that it doesn't change, but it actually does. Not as much as, say, a air pressure test on a propane or natural gas line, like when you're first installing it. It doesn't jump as much, but it does move. You just want to see if you're going to be losing your nitrogen pressure. And if you don't, then you can go ahead and release that nitrogen pressure and then start your vacuum procedure.
Yeah, and you pointed out some really good things here, because I recently did a nitrogen pressure test procedure illustration that I did not remember to point out the evaporator test, observing the evaporator test pressure. So you've given me an edit that I need to make now. And that's a really good one. But also keep in mind that it's really, when you're nitrogen pressurizing, just look to the lowest number and make that your maximum number you got to hit. Because in some cases, and this is something that a lot of people forget, if you are pressurizing inside of your condensing unit, your compressor shell and therefore your fusite terminals are on the low side of that system. And a lot of people miss that because they think of the compressor being on the high side, but actually most of the compressor is on the low side. The entire shell of most of the compressors we work on is on the low side. So you definitely want to be careful with not overpressurizing. And in fact, if you're like me, when I started in the trade, we would often pressurize systems to 60, 70, 80 psi. I mean, again, this was on the R22 days, but that was pretty standard for pressurizations, especially when you're looking for a hisser, as we call it. You know it's a big leak. You're probably not going to have to use any real advanced techniques. You're just getting enough pressure in there so you can hear where it's leaking out. Your first leak detection procedure is your senses, your ears, your eyes. Is there signs of oil, that sort of thing? Yeah,
you hit it on a good point right there. Anytime when I was doing an installation, you're installing the system, and then you're thinking, hey, did I tighten down the piston chamber, or whatever, or the TXV, the nut there with the Teflon ring? Did I tighten that down? Did I tighten down the flare connection on the external equalizer for the TXV? You want to, first, when you're doing your nitrogen pressure test, you want to make sure that you don't have a hisser. You're going to just pressurize it to even 25, 50 psi and stop. And then just wait and see, is the pressure going down immediately? Because you're, say, outside and you may not have tightened something inside. There's no sense in going much higher until you make sure that you're past your first point. Maybe you just pressurize it to 25 or 50. So yeah, don't waste your nitrogen bottle on something that you have. You braze all your joints, but you forgot to tighten that one connection together.
Or you completely forgot to braze an entire joint. I did that the other day. This is confession time for me. I installed a new system at my own house with my 16-year-old son, who has already learned how to braze and some other things. And I went outside and started pressurizing it, and he just came down laughing at me because it was quite a hisser, seeing as how it was not braced at all. So anyway, remember to brace your joints. That's another good reminder.
Yeah, absolutely.
All right, so that's kind of I want to make that distinction between nitrogen pressurization, leak detection, and now let's talk about if refrigerant's in the system, some of the different technologies. So let's first talk about heated diode, because that's one of the most common out there. In your mind, what are some of maybe the advantages, disadvantages of the technology, and maybe some of the techniques?
With the heated diode, I was always concerned about how quickly I'm going across all the joints, or going across to the fins and everything else. You got to monitor when the sensor in the front, if it's getting older, if it's not picking it up as well as it used to. So those are things you want to keep on top of. No matter what tool you're using, make sure you have a good battery. Some of the tools don't tell you when it has an old battery. I was actually just talking with an electrician friend of mine the other day, and he switched the batteries out in his thermostat twice with brand new batteries. And then he got a new thermostat. And lo and behold, the new batteries he was installing were no good from the package. So make sure that you even test your battery before putting it into whatever leak detector you're using. But the heated diode, depending on what model and the type and brand you get, are pretty good at smelling the leak. So whether it's a R22 HCFC or a R410A HFC detector, you're just going to want to make sure you make your passes over everything. And if it's real windy, you're going to want to maybe block off the section so it's not pushing the chemical away from the sniffing point, the end of the tool.
It's common sense stuff. Interesting thing about different designs is you'll get some designs where they place the sensor all the way at the end, so that way it doesn't have to go as far. And then you have some designs like the H10 where that gas has to snake all the way down that tube, and you got to know that about your device, because if it has to snake all the way down that tube, you may get a hit. Oh, I got a hit here. Well, that may have actually come well earlier in the process. Another thing is recognize with heated diode that the sensors, they do start to drop in sensitivity, and some of them will allow you to adjust up the temperature on the heated diode in order to get your sensitivity back. But then you have to dial that temperature back whenever you replace the sensor. So the thing is, sensors got to be matched for the refrigerant you're testing to make sure that it's actually going to react with the gas that you're measuring. And keep in mind that those sensors over time are going to weaken and to the point that they become completely ineffective. And that's where I think a lot of people who use heated diode who aren't getting good results often don't recognize that. Maybe at one time they were able to find leaks and now they can't find them anymore. Often it's because you got to swap that sensor out.
And you hit it on a good point right there. Depending on where the sensor placement is, you really got to know your tool. So whatever tool you're using, you have to have an intimate knowledge about that tool and have confidence in it. And that even goes all the way to like even your vacuum setup or whatever. You use that same setup every time because it's able to pull a deep vacuum. Well, same thing with your leak detector. You got to know how to use it because you'll go right past the leak, and then when your device is getting triggered, it smells the chemical. The same thing with the infrared. You have to go past it. You have to make multiple passes, and then you have to kind of once it goes off, go back to where you were and kind of keep dialing in back and forth until you hit the target area. So you just really, really need to know how your tool works and how the different model differentiates between another manufacturer. So yeah, absolutely.
Yeah, infrared is a really interesting technology. Moving right on to that, and you mentioned it. You have to keep moving it. Interesting distinction. If you take a heated diode and you stick it right on a leak, it'll just sit there and scream until the battery dies, right? Yeah. You take an infrared, you stick it on a leak, it'll go, and then it'll just stop. And it's like, oh, well, maybe that isn't the leak. But it's because it's constantly doing this comparative analysis of the concentrations that it's measuring versus its previous measurements. Now, not all of them work that way. So there are infrared leak detectors that you can spend a lot of money on, like the Stratus or the PGM-IR, that do it a little differently. The PGM-IR is actually constantly measuring against kind of a pure sample that goes through a filter, but it also has to kind of do this recalibration periodically. Now, not knocking the tool. We love it. We have a ton of them in our grocery segment because it actually shows concentrations of refrigerants in ppm, which is interesting. Mm-hmm. Once again, like my son, who's a new technician, a young technician, got the Stratus because I told him, he's like, "What's the best leak detector out there?" I'm like, "Well, go ahead and get the Stratus." It was mostly just having fun to see if he would buy it, and he did. And he used his tool fund money, because we have tool funds. Used his tool fund money to buy the Stratus. And when he first got it, he hated it. He's like, "This thing doesn't work at all. I can't figure out how to use it." I'm like, "Well, did you read the manual by any chance? Like, did you actually?" Because it's not the same at all as your H10 or your Testo or whatever you're using before. And now he likes it and is used to it. But to your point exactly, they almost couldn't be more different in terms of how you use them. I mean, they both sample gas and work in that way, but they really are different practices, and you have to just be confident and comfortable with your own leak detector.
Yeah, absolutely. Questions come in on the YouTube channel about leak detection, and a lot of times it comes down to I find the PDF of the manual for the tool, and it may be ultrasonic or it could be heated diode or whatever it may be, and they just got to know how the tool works. That's it. And so I point back to the manual of that particular tool. Hey, this is how it works, and that could even come to like a furnace or an air conditioning system. I end up going back, pulling the manual and saying, line blah 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 right there, it says this, and that's it. You know what I mean? And so just read the manual. If you just go around and read all the manuals, you're going to be awesome within your company. Everybody's going to come to you and ask you questions. You know why? Because nobody ends up reading the manuals. Are you kidding me?
That is absolutely 100% true. It was hilarious. I was 19 years old working at this very large company, and people would always say some version of, "How do you know that? How do you know all this?" It's like, hate to break it to you.
It's right there.
I literally just read the manual. That's all I did. It is funny how that works. I was talking with Eric Melly, who's one of our senior techs, who's been on the podcast a lot. He was over for dinner, and we were just talking through that. He's like, people are always like, "Oh, you're such an amazing technician," but mostly it's to what you're saying. You don't even have to know everything.
Right.
You just have to know your own stuff. You have to know your own tools. If you work in a market, for example, where you never work on heat pumps, well, then maybe you don't need to worry about heat pumps. Maybe then if you're working on high efficiency gas, just really know the furnaces that you work on all the time. It's not that there isn't value in learning heat pumps and all that if you're interested in it, but what you see is people who will do the same mistake over and over and over again because they don't just take the time to understand their own tools and understand the equipment that they're working on. If it takes you an hour to read through the manual, but now you know a lot about this equipment, and now every time you go back to it, you're going to be that much better. It really is that simple. Like, I get why people don't. You get a lot of people who will make fun of people, like, "Oh, well, don't you know how to read all that?" We're all busy. Most of us are overworked in the trade, and you get impatient, and I get it. But yeah, you got, especially with your tools. It drives me nuts when guys will, because we had so many H10s over the years, and they'll come and say, "Oh, it's broken. Hey, can you send it in for me?" It's like, what have you done so far? Have you checked the filter in the tip? Have you replaced that? Have you checked to see if the pump is, moving the little red bead inside the probe? Have you replaced the sensor anytime? Have you looked to see if it's even heating up? Almost never. It's always just, it's broke, send it in. It's just such a waste. These things are designed to, some of them are designed to be serviced, like the H10. I mean, you can literally fix almost anything on that leak detector, and they're not all that way. Let's talk about the limitations of leak reactant, which I need to stop calling it soap bubbles. Because when I call it soap bubbles, then sometimes people get the idea that you're literally taking dish soap and mixing it with water and using that, and that's, like you said, not a good idea.
I mean, and to that point, I had the different manufacturer reps in the classroom with corrugated stainless steel tubing, like gas lines, and they would always tell you stories and show you pictures of where somebody used soapy bubbles, meaning like soap and water, on corrugated stainless steel tubing, and it just ate a hole through, and they have a huge gas leak, and all these gas leaks all over the place, and the same thing with galvanized pipe or black iron, and then also copper, so we got to make sure we stay away from that, even though the answer to the test, in the EPA 608, it's soapy bubbles.
Soapy bubbles, yeah.
But it's anti-corrosive bubble leak detector.
Right.
But it's but you're right, people get confused by that. What were we talking about now?
We were talking about how Big Blue is the best leak detector. Leak reactor to use.
Big Blue is really good.
I gotta give John Pastorella a little bit of love there.
Say.
He did make some really good stuff. So
he did.
We like it.
I've used that since I started in the trade way back when. And it makes the best bubbles. And when I'm doing leak detection on the Schrader valve, the valve core in the port, I put the cap on, drill a little hole, and I put just a little bit of their Big Blue on it, and just you have a huge bubble form. If you have a leak, and it's awesome.
Yeah. That is actually, and I don't know why I never thought of that, because I recently talked about how what I'll typically do is I'll pull the seal out of the cap, and then I'll put the cap over it, and then I'll bubble it, and it'll bubble around the edges. But your way is even better. Leave the seal in it. Right. Just have one that's basically for that purpose. Drill a little hole in it, and now it'll make really nice bubbles out of that little port. So really good idea. You should patent that.
I thought about it, but it's just a hole.
That's what the patent application would say.
Right. It's a hole. Hole in the cap.
Take a cap, put hole in it. Invention. Yeah. I think that's it. Yeah. So soap bubbles are great, especially if you see signs of oil.
Yes.
I don't know if you do this, but when I see signs of oil, I pretty much go straight to bubbles. And if you're using the right kind of, again, leak reactant, you're using Big Blue basically. Right. You don't have to worry about it setting off your leak detector and all that. Although I've heard some people say that it does. I think there must be some sort of secondary reaction that's happening there, because I've never had it set off my leak detector.
I haven't either with the tools that I've used in the past. No, I haven't had any issue with that. And like you said, with the bubbles on microchannel, that Big Blue works pretty well, because you can get on both sides. If you get inside the unit with the microchannel, you get one side, and then you get to the other side, it's going to force a bubble to grow because you're closing off the cavity. Whereas with a regular coil, it's a little bit harder, because you have to get your bubble leak detector kind of in through the fin, to that leak. But it still works, and that's the kind of, you want to put the bubble leak detector, especially on all of those 90s. A lot of times it's right near the compressor, with the vibrations, and you see that oil. And I always love when you go up to a system and it has zero pressure in it. You're like, yeah, because it's going to be a hisser. You put the nitrogen pressure in there, and boom, you can just hear and find a leak. It's real quick. That's great. But a lot of times it's more in depth.
Cool. Final one that I wanted to mention for companies. This really isn't so much for technicians. This is for companies because I've done this a few times and it isn't a good practice. I actually set up a whole policy and procedure on doing it every time, and that hasn't happened. I know that may be a shock to some people, but sometimes people don't listen to me even in my own company. Would love companies to do more of is to have a water tank out back.
Yes.
And when your technicians condemn evaporator coils, because
Fantastic.
evaporator coils get condemned incorrectly a lot. I mean, I know it's hard to believe, but they do. Pinch them off, seal them, pressurize them, and dunk them in the tank because that is sort of that's the best way to leak detect anything, pretty much.
Yeah, I had one of those in the classroom. I just built a tank, and we just dunked the evaporator coils in, and it was interesting to see that it wasn't just one or two leaks, and so that's the issue as well because. And even when I was out in the field full time, I would say to the customer, now look, I can fix the leaks that I'm finding. I don't know if there's some other one somewhere else. Right. There may be 2-3 leaks on an evaporator coil. A lot of times it's a lot of leaks.
Right.
And you can't just go and fix every one of them. In that case, it's better to just replace that evaporator coil with a new one. But that tank is beautiful to tell if somebody is correct in their diagnosis with your employee, or not. And it just kind of gives them that real life application. Are the leaks happening on the back of these evaporator coils? Is this particular model of coil?
Right.
Is this coil failing because the tube is too thin, and that's happening because the manufacturers maybe tried to make it too energy efficient. So it gets you to know the real life application of where the leaks are occurring, and it lets you know why they're occurring. And that's, the more knowledge you have, the more you can apply it on the next job, and you know where to look. Even if it's for that particular model of evaporator coil, hey, these are susceptible in this area.
Yeah, and from a business insight standpoint, it's great. I think a lot of people think when I say things like this, it's about showing up a technician, and it really isn't. It's about maybe they said the leak was in the front right, and it's actually in the back left. And just saying, okay, let's look at how you're doing leak detection. Everything in the air conditioning business, and this is more of a business side of things, is an iterative growing process. It's like your pricing, the way you quote jobs, all this stuff you learn from previous jobs, but only if you have enough data. Like if you are just pushing on to the next job and you don't know how you did on the last job, you're going to keep making the same mistake. And this is an example of this. Leak detection, there's a lot of mistakes made, and it is an area that when you make mistakes, they can be very costly because now you got to give that customer refrigerant for free and then repair what actually is the cost, and maybe you have to refund them the previous thing. It can get really costly quick.
Refrigerant leak detection is one of the biggest problems, that is not an easy solution. It happens, and say a building owner or manager is used to you being able to go in, find a leak, and fix it and be out. Whether that's a natural gas, propane leak, or a water leak. But those are, I feel like a lot easier to find than a refrigerant leak. And then you have the problem with the evaporator coil. You can't even get to the back, unless you try to cut a hole, or you depending on how the evaporator coil is facing, you can't get access to certain parts. And it's just one of these things that, all I can say is the same thing I said over and over, which is to get very experienced with the tool that you have and know that you can find a leak. Be used to figuring out how to find them. Because you can't, there's only so long that you're going to be able to dance around and play. Oh, the leak is over here in the evaporator coil, or it's in the line set, or it's in the outdoor unit. And it's not fair, or it's not right to say the building owner that you're just guessing. And I think a lot of that happens in the field. A lot happens because there's a lot of companies may not buy some type of electronic leak detector, or they're just relying on, so last time the leak was there, so this time I'm going to say the leak is there, in that same spot. And it's just not right.
I think we've covered it. Remind people how they can find all your great stuff, your books and all that other stuff.
So we have our book on refrigerant charging over at our website at acservicetech.com, and we have the full outline there so you can see all the topics that are included in that book. And we have a 1,000-question workbook as well, and it comes with an answer key so you can self-check. You can check to make sure that you're answering them properly. You can go to our website at acservicetech.com. We have some PowerPoints for teachers there, and we've got posters for teachers. And we have our book, our workbook, and so, we're excited to find out when they're being used in the classrooms, and so, that's awesome. I really love that, and I'd love to see those posters hung up in classrooms across the nation, Canada, everywhere. And we also have our physical products available over at Amazon. We have our ebook over at our website at acservicetech.com, and also on Google Play and iTunes, we have it there as well.
Nice.
So, but make sure to also take advantage of all the free resources over at the website, such as the articles, the quizzes, calculators, the podcast, and things there.
Yeah, and never to forget the YouTube channel.
Yes, the YouTube channel.
The YouTube channel. Yes. The thing that started it all.
Yeah.
All right, thanks, brother.
Thank you.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.